The universe has always whispered secrets through the silence of its dark expanse, but every so often it does something stranger. It shouts in a language of riddles. Somewhere beyond the settled borders of the familiar solar system, far from the warmth of the sun, an ancient traveler drifts. It is designated 3I Atlas, the third known interstellar object to ever trespass through our neighborhood of stars. Yet this time, the visitor does not journey alone. Astronomers peering into the abyss have reported the presence of 10,000 faint companions, like a ghostly armada trailing behind a single cosmic flagship. Imagine a comet, a shard of ice and dust from another sun, cast adrift and flung across light years of emptiness. Alone, such a wanderer would be astonishing enough. But what has unsettled the world of astronomy is not the singular presence of 3I Atlas, but the improbable multitude that follows in its wake. Tiny specks, faint as whispers of light, yet organized in a way that demands explanation. 10,000 bodies, coordinated, moving as though bound to a secret rhythm. Their existence breaks open questions that touch the very framework of physics. Why would so many accompany one? How could such a swarm survive intact across the gulfs of interstellar space? And what, if anything, do they want to tell us about the origins of matter, gravity, and time itself? For the telescopes that revealed them, this was more than observation, it was intrusion, a reminder that the universe is not quiet, not settled, not obedient to human expectations. It carries shadows with intention, formations that make the imagination ache. If Oumuamua, the first interstellar wanderer, was a puzzle, then 3I Atlas, with its countless companions, is a cosmic storm written in silence. Here, on the edge of science, we stand before a swarm that should not exist. 10,000 fragments, moving together like a choir of ghosts, a hymn written in gravitational ink across the blackness of space. It began, as so many cosmic revelations do, with a flicker of light barely distinguishable from background noise. In 2019, the Atlas Survey, an acronym for Asteroid Terrestrial Impact Last Alert System, was gazing into the void from its perch in Hawaii. Designed to watch for threatening asteroids that might cross Earth's path, its mission was rooted in planetary defense. But often, when human technology watches the skies for one reason, the universe answers with another. The discovery of 3I Atlas emerged from these watchtowers of vigilance. Its motion betrayed it, a faint object moving too swiftly, at too steep an angle, to be native to the sun's dominion. When calculations confirmed its hyperbolic orbit, astronomers recognized it immediately as something extraordinary, an interstellar traveler, a body birthed beneath another star and now crossing into ours. This alone would have secured its place in astronomical history. But in the days and weeks following that detection, strange anomalies crept into the data. Small, consistent variations in brightness, shadows not belonging to the primary body, suggested companions. At first, skepticism reigned. Surely these were artifacts, errors in calibration, phantom blips from the sensitive detectors. The instruments had been pushed to their limits, peering into the faintest edges of detectability. Yet as more observatories joined the watch, Harvard's collaborators, space-based telescopes, ground-based surveys, the pattern refused to vanish. Everywhere the instruments pointed, they saw echoes trailing behind 3I Atlas, like sparks shedding from an invisible fire. NASA's near-Earth object programs confirmed it. Not one, not a handful, but thousands, 10,000 distinct points of light, faint yet undeniable, tracing a coherent wake behind the interstellar wanderer. No comet from our system had ever carried such an entourage. No asteroid broke apart with such tidy persistence. It was not the story astronomers thought they were reading, but something stranger, something more demanding. In Harvard's halls, whispers turned to fevered debate. A swarm, an escort, a fleet, it seemed impossible. But the universe had placed its evidence plainly in view. Humanity had stumbled not just upon a single cosmic vagabond, but upon a procession, a celestial migration marching into the pages of history. The memory of Oumuamua still lingers in the corridors of astronomy, a ghost that refuses to leave. When it sliced through our solar system in 2017, it carried with it the shock of the unknown, a cigar-shaped fragment tumbling oddly, accelerating in ways that gravity alone could not explain. For many, it was the first taste of interstellar mystery, an object from another star system arriving without warning, then vanishing into the abyss. Harvard's Avi Loeb dared to suggest it might even be artificial, a relic of technology beyond our own. Others countered with icy explanations, cometary models, or exotic natural processes. But Oumuamua's strangeness never fully yielded. It remained unsolved, its questions still echoing. So when 3I Atlas was identified, the scientific world was prepared, or at least it believed it was. The name itself, 3I, the third interstellar object, already spoke of a growing lineage. And yet, as the data sharpened, it became clear that this new visitor was not merely Oumuamua's successor. It carried a different kind of enigma. For if Oumuamua, confounded by its lonely peculiarity, 3I unsettled by sheer abundance. Astronomers remembered the frustration of those earlier debates, the missing clarity, the too brief window of observation, the way Oumuamua escaped before answers could be found. With 3I Atlas, there was determination not to repeat that failure. The swarm changed everything. It was not a solitary enigma vanishing into the dark, it was a legion, extended in time and space, a phenomenon too vast to ignore. Where Oumuamua was a riddle in isolation, 3I Atlas presented itself as a chorus of mysteries, each faint body adding another question. And so the echoes of Oumuamua coloured every discussion, every paper drafted, every sleepless night before a telescope screen. If the first interstellar visitor had shown us the fragility of our understanding, this one threatened to expose the insufficiency of our very models of cosmic order. Oumuamua had unsettled. Atlas would destabilize. The eyes that found 3I Atlas did not belong to a single astronomer staring through an eyepiece, but to a machine, an array of telescopes designed to sweep the sky tirelessly, night after night. The Asteroid Terrestrial Impact Last Alert System, or ATLAS, had been built for vigilance, not wonder. Its duty was pragmatic: to spot dangerous objects on collision courses with Earth, to serve as an early warning system for cosmic threats. Yet science often blooms from unintended directions. Atlas, mounted on Hawaiian peaks where skies stretch clear and black, scanned the heavens for moving dots. In those shifting pixels, it distinguished between the stars fixed, eternal on human timescales, and the wanderers, the small specks whose subtle drifts betrayed their orbits around the sunday. Normally, its catalogue filled with asteroids, comets, debris, but one faint trace resisted categorization. As soon as the trajectory was plotted, alarm and awe spread through the community. Its path was hyperbolic, meaning it was not bound to the sun at all. It came from elsewhere, from another star, another cradle of planetary formation. Harvard scientists, collaborating closely with NASA, poured into the data. They brought in additional instruments, from the Canada, France, Hawaii telescope to spectrographs scattered across the world. Every observation confirmed the extraordinary truth: 3I Atlas was interstellar. But telescopes do more than detect, they contextualize. When Hubble turned its gaze, when deep sky surveys sharpened their focus, the story complicated. Trails of faint points accompanied the main body, each one requiring careful distinction from background stars, noise, or instrumental illusions. It was as if 3I Atlas carried a cloak woven of smaller fragments, orbiting or drifting in loose formation. The data teams, spread across observatories, rechecked, recalibrated, repeated the process. The anomalies remained. Thus began the saga of the swarm, a discovery born not of intention but of persistence. Atlas had been built to protect our planet, yet it had stumbled upon a mystery that threatened not impact, but imagination. 10,000 faint companions hidden in the black fabric of interstellar night. Counting the swarm was like trying to measure a shadow with trembling hands. In the early days after 3I Atlas was confirmed, astronomers faced a problem of scale. They could detect the primary body easily enough, faint but distinct. Yet around it, like embers trailing from a dying fire, tiny points of light scattered across telescope frames. Each time exposures were lengthened, more companions appeared. What seemed a cluster became a cloud, and what seemed a cloud became an armada. The challenge lay in separating truth from illusion. Telescopes are easily deceived by dust streaks, cosmic rays, sensor noise. Astronomers at NASA and Harvard had to apply painstaking statistical filters, cross-referencing multiple observatories, eliminating false positives one by one. What remained, after months of effort, was staggering. Not dozens, not hundreds, 10,000 distinct objects, all following the interstellar traveler's path. To count in this context was more than tallying points of light. It meant assigning orbits, tracing faint arcs against the starfield, projecting their motions forward to confirm allegiance to the swarm. Supercomputers processed terabytes of data, refining probabilities, discarding anomalies until the picture sharpened into something undeniable. This was no accidental scatter, no temporary shedding of dust. These were solid bodies, kilometer scale in many cases, faint yet stubborn in their coherence. For the scientists, the numbers carried a weight of dread. The solar system itself contains swarms Trojans trailing Jupiter, asteroid families bound by gravity. But never had so many bodies been seen crossing into our neighborhood together, carried from beyond the sun's influence. 10,000 wanderers arriving at once, strained not only instruments but imagination. The cosmic census was complete, and its result was a ledger of improbability. Something had gathered this multitude across light years, binding them in a journey that defied chance. The universe had delivered not a visitor, but a caravan, a migration too vast to be ignored. When astronomers first plotted the swarm in detail, an unease crept through the data. Comets often fragment as they approach stars, breaking into smaller shards that trail like a glowing veil. Asteroids can split under stress, scattering siblings into erratic families. Yet the behavior of the companions surrounding 3I Atlas did not resemble these familiar stories. They did not disperse chaotically. They did not fade as dust should. Instead, they persisted 10,000 small shadows marching in lockstep, faint but ordered, as if obeying a hidden law. The contradiction was stark. According to standard celestial mechanics, the violence of interstellar space should have scattered such fragments long ago. Radiation pressure, collisions with dust grains, encounters with stray stars, any one of these forces should have shredded coherence across the eons. But here they were, intact, coherent, following a trajectory as though bound by something more than chance. Scientists began to murmur words they did not wish to publish: anomaly, impossibility, paradox. For if the swarm were a simple debris field, its statistical spread would be wide, chaotic, unpredictable. Yet their distribution was narrow, elongated like a disciplined formation trailing their leader. It was too neat, too deliberate. Harvard's analysis compared their brightness profiles to known cometary dust tails. The conclusion was unsettling: they did not match. These bodies reflected light more like asteroids than gas-rich comets. And yet, asteroids do not travel in vast synchronized flocks across interstellar gulfs. It was as though the universe had presented a contradiction in physical form, daring scientists to reconcile it. Shadows that should not exist, matter behaving outside the script written by centuries of Newton and Einstein. Some whispered of unseen forces, others feared errors, but as more telescopes confirmed the swarm, the excuses withered. What followed 3I Atlas was not an illusion, it was a presence that science could not yet fit inside its ordered cage of rules. Celestial mechanics has long provided humanity with certainty. Newton's equations chart the arcs of planets with uncanny precision. Kepler's harmonies describe the music of their motion. Einstein deepened the script by curving the stage itself, space-time bending to the weight of mass. With these laws, comets return on schedule, moons hold to their orbits, and asteroids wander where gravity permits. Yet when astronomers tried to apply this framework to the strange procession of 3I Atlas and its companions, the calculations wavered. The question was simple: how could 10,000 bodies, weakly bound and fragile, move together across interstellar space? Gravity between them was negligible. Radiation pressure should have peeled the smallest fragments away long ago. Random encounters with molecular clouds should have scattered them into oblivion, but instead they remained as though tethered by invisible threads. Some scientists suggested a shepherd effect. Perhaps the central mass of 3I Atlas exerted just enough pull to corral its followers, like a faint star holding a cometary halo. Yet simulations faltered. The swarm's density was too great, the distances too vast. The central body lacked the mass to control such a multitude. Others invoked resonance, patterns of orbital rhythm that might emerge naturally, aligning fragments into a train. But resonance requires structure, a parent system to seed it. Out here, there was nothing but emptiness. The deeper the equations were tested, the more they resembled riddles rather than answers. Some fragments appeared to drift ahead of 3I Atlas, others behind, yet all remained aligned with its path, as though acknowledging a command. Astronomers, unwilling to invoke intention, clung to metaphors instead. They called it an escort, a migration, a caravan of shadows. But beneath the language lingered unease. Celestial mechanics said such a phenomenon should collapse, scatter, dissolve. And yet it did not. The physics of escorting had no precedent. It was as though the swarm obeyed a rule unrecognized, a principle not yet etched into textbooks, a reminder that even the most trusted laws might be provisional, awaiting correction by the silence of the cosmos. Numbers have a way of unsettling when they refuse to fit the frame of expectation. 10,000, an almost biblical figure, far beyond the comfort of probability. For astronomers used to cataloguing asteroid families or cometary fragments, such density emerging from interstellar space was not just unlikely, it was nearly absurd. Statistically, no known process of planetary birth or stellar death should produce so many objects traveling together for so long. The problem deepened when researchers modeled the odds. A star system might eject debris during the chaos of formation, scattering icy bodies into the galaxy. Yet the natural outcome is randomness. Fragments flung in every direction, their paths dispersing across light years. What are the chances, then, that 10,000 of these fragments would remain not just intact but coherent, clustered, marching behind a single larger body? The simulations gave the same answer again and again: vanishingly small. A number so close to zero, it may as well have been silence. To cosmologists, this improbability was not a curiosity but a crisis. For if nature produced swarms like this, why had none been seen before? Was this the first of many to pass unnoticed, or was it genuinely unique? Each option strained belief in different ways. Uniqueness suggested some hidden mechanism at work, some cosmic event beyond ordinary physics. Commonness implied the galaxy was filled with unnoticed caravans and that human eyes had simply been blind until now. What made the improbability unbearable was survival. To travel interstellar space is to endure collisions with dust, erosions by radiation, gravitational disruptions by stars. A small group might endure, but 10,000 surviving intact across unmeasured ages was a mathematical mockery. As Harvard researchers admitted in careful tones, the swarm's persistence suggested an organizing principle beyond chance. It was as though probability itself had been defied, a statistical impossibility floating silently through the void, asking questions humanity was not ready to answer. Numbers, normally a source of reassurance, had become an omen. Tracking the swarm became a test of human patience and technological endurance. The primary body, 3I Atlas, was faint but manageable. Large telescopes could hold its trail against the shifting backdrop of stars. But its companions, tiny fragments, barely brighter than noise, tested the very limits of detection. Each night's exposure yielded a fragile tapestry of points, some real, others artifacts of the sensor. To follow them required not just vision, but discipline. NASA and Harvard's teams coordinated globally. Telescopes in Hawaii, Chile, the Canary Islands, and orbiting observatories like Hubble and Gaia each took turns keeping the swarm in sight. Yet even with this network, the task was Sisyphean. The objects were small, dim, and scattered across a field wider than most instruments could hold. By the time a single frame was captured, the swarm had already shifted. It was like chasing shadows with lanterns, never quite able to catch their full shape. Software became as crucial as glass. Algorithms sifted through thousands of images, teasing faint specks from the noise. Statistical models predicted their next positions, guiding telescopes toward targets so faint that even minor errors could mean complete loss. More than once, astronomers feared they had lost the trail altogether. Then, after hours of processing, the points would reappear, clustered again, still stubbornly following their leader. The difficulty was not only technical but emotional. To chase these fragments was to live in a tension between presence and absence, between detection and vanishing. The swarm seemed to play a cosmic game of hide and seek, daring humanity to keep watch. Each confirmed reappearance was a triumph, each loss a reminder of how fragile our gaze is against the infinite dark. Tracking them was like listening to an ancient rhythm faintly heard through static, a song carried from another star. The swarm moved on regardless of human effort, patient, implacable, as though indifferent to the eyes struggling to keep pace. It was not meant to be easily followed, and yet it drew humanity's vision onward, deeper into the enigma of the interstellar night. Light, when broken apart, becomes a language. Each photon carries a story of the substance it touched, the minerals it struck, the ice it reflected, the atoms it absorbed and re-emitted. For astronomers, spectroscopy is the grammar of the cosmos, the way to decode the silent materials of distant bodies. When 3I Atlas and its companions revealed themselves, the next step was obvious: catch their light and listen. Yet these objects resisted clarity. Their faintness was extreme, their signals blurred by distance and time. Still, patient work with large aperture telescopes gathered spectral data. Fragile though it was, what emerged was a puzzle. The main body, 3I Atlas, showed signs of volatile ices, much like a comet. Water vapor, carbon monoxide, hints of frozen organics, ingredients familiar, though carried from another star, but the swarm did not echo its parent. The faint companions reflected light differently, their albedo suggesting surfaces darker, more akin to asteroidal fragments than icy comets. Some showed spectral slopes consistent with carbon-rich material, primitive and unaltered since their birth. Others hinted at metallic inclusions, glittering faintly in the starlight. Together, they painted a picture of variety, not uniformity. This was no simple shedding of material. It was as though the swarm carried a sampling of a system: rock, ice, carbon, metal, all bound in an unlikely caravan. Equally strange was their lack of gas. If they were cometary shards, they should have left faint halos of sublimating vapor as they warmed, yet the swarm remained eerily silent. No tails, no glow, only hard, persistent reflections. The light told a story of age, of surfaces weathered by radiation, scarred by eons of exposure. These were not fresh fragments, but ancient travelers, hardened by time. In Harvard's reports, a phrase began to recur: spectral fingerprints. Each object bore its own signature, yet together they formed a collective too coherent to ignore. It was as though the swarm were not the children of a single parent, but the choir of a vanished world, a mosaic of matter carried intact across the abyss. The light had spoken, and its voice was unsettling, for it suggested not uniform birth, but deliberate assembly, a fingerprint too complex to dismiss as chance. Einstein once described his theory of relativity as a harmony of geometry and motion, a rewriting of the very fabric on which the universe is embroidered. Planets curve through space-time not because they are pushed or pulled, but because the fabric itself is bent. For over a century, relativity has guided astronomy with unwavering accuracy. The bending of starlight near the Sun, the precession of Mercury's orbit, the ripples of gravitational waves whispering from colliding black holes. Yet in the quiet persistence of the swarm trailing 3I Atlas, some physicists sense a discordant note, a place where the harmony falters. If the swarm were truly free-floating fragments, relativity predicts they should scatter, following hyperbolic paths like sparks from a firework. Their weak mutual gravity cannot hold them, the central body too small to shepherd them across interstellar gulfs. Radiation pressure from stars, collisions with drifting particles, even the curvature of space-time itself should disperse them, and yet they do not. They remain coherent, as though immune to the entropic spread that relativity implies. In modeling attempts, astronomers have tested general relativity against the swarm's dynamics. Some patterns suggested minute deviations, trajectories bending more tightly than gravity alone could account for, alignments too neat to be explained by random chance. Critics warned against overreach, noise, measurement error, wishful thinking, but the stubbornness of the coherence gnawed at confidence. Could Einstein's geometry, flawless in so many other arenas, conceal subtleties only revealed by this improbable procession? The ghost of relativity, as one Harvard researcher called it, hangs over the debate. For Einstein's theory does not break easily, it bends and stretches but resists collapse. If the swarm resists its predictions, then either new physics whispers from its formation, or humanity has misunderstood the very stage on which cosmic motion unfolds. Perhaps, some suggested in hushed tones, the swarm is less an object than a test, a natural experiment offered by the universe itself, asking whether the equations that guided the 20th century can bear the weight of the 21st. If Einstein's ghost haunts this caravan, it may be because the future of physics itself is hidden in its silent drift. The lecture halls of Harvard have long been places where ideas collide as fiercely as stars. Here, under the weight of mahogany beams and the gaze of portraits of past visionaries, the debate over 3I Atlas and its companions reached fever pitch. Astronomers, cosmologists, and theorists filled auditoriums with charts, equations, and images projected like fragments of a dream. What was this swarm? A cometary dispersal unlike any before? A galactic migration held together by physics yet unimagined? Or something stranger still? Some argued for restraint. These are fragments, one group insisted, their voices steady. A disruption event, a comet shattered near its birth star, its pieces flung outward yet improbably aligned. They pointed to the wide spectrum of compositions, icy, rocky, metallic, as evidence of a parent body torn apart, scattering its diverse interior. But others countered with statistics. The survival of 10,000 fragments across interstellar gulfs defied probability. The coherence of their alignment mocked every natural dispersal model. Skeptics dismissed the notion of anything beyond chance. Coincidence magnified by imagination, they muttered in hallways. Yet even they could not deny the stubborn data. NASA's instruments, ground-based telescopes, and independent observers all confirmed the swarm's persistence. Coincidence becomes harder to defend when repeated across continents, across nights, across methods. It was Avi Loeb, already infamous for his defense of Oumuamua's possible artificiality, who once more fanned the flames. "What if," he asked quietly but firmly, "this is not random at all? What if the coherence is intentional, not the accident of physics, but the trace of engineering on scales we can barely conceive?" The room stirred uneasily. The suggestion was provocative, yet the mystery demanded space for uncomfortable possibilities. The Harvard debates stretched late into the night, voices echoing like arguments with the cosmos itself. Some clung to natural explanations, however improbable. Others allowed themselves to flirt with radical speculation. But all shared the same uneasy awareness. Whatever the swarm was, it stood beyond precedent. And in that uncharted territory, even the sharpest minds found themselves groping through a fog of uncertainty. In those debates, one truth became clear. 3I Atlas was no longer just a discovery. It was a challenge, a demand that science confront not only the boundaries of physics, but the boundaries of imagination itself. Gravity is the silent sculptor of the cosmos, invisible yet inexorable, shaping the paths of moons and the fates of galaxies. Its laws are clear, its pull universal. And yet, when astronomers mapped the faint trajectories of the swarm trailing 3I Atlas, something peculiar emerged. The clustering of these bodies did not spread randomly, as fragments should. Instead, they arranged themselves in patterns, subgroups, and filaments that hinted at design rather than decay. The swarm's distribution resembled a loose braid, strands of objects bound together, sometimes converging, sometimes parting, but never dispersing entirely. Models run through supercomputers predicted instability. Such structures should unravel, dissolving into chaos under the influence of time and distance. But observation defied the models. The swarm seemed to resist entropy, as though maintained by an unseen hand. Some theorists suggested gravitational shepherding, tiny but persistent nudges from a massive object hidden within the swarm, too faint to detect directly. Perhaps a dark companion lurked there, a planet-sized remnant, or even something stranger, a primordial black hole, ancient and quiet, guiding the procession like an unseen general. The idea stirred fascination and fear. For if a black hole were hidden within the swarm, then the caravan was no mere anomaly. It was a herald of forces capable of swallowing stars. Others proposed external influence, the tidal pull of galactic structures, the faint but cumulative tug of dark matter halos. Perhaps the swarm was shaped not by itself, but by the larger architecture of the galaxy, guided along filaments of invisible mass that stretch between stars like cosmic scaffolding. Whatever the explanation, the gravitational riddles left scientists unsettled. The swarm's orderliness felt less like debris and more like choreography, a dance to music no human could hear. And in that choreography, Some saw a mirror of our ignorance, a reminder that gravity, for all its universality, still hides mysteries. Perhaps the swarm was not simply following 3I Atlas. Perhaps both leader and companions were obeying a deeper command, gravity, rewritten in a dialect we have yet to understand. The notion that these objects might have traveled together for eons stirs a deep unease. Stars are born in nurseries, dense clouds of gas and dust, where gravity weaves matter into suns and planets. In such chaotic beginnings, collisions and ejections are inevitable. Vast populations of icy bodies are flung outward, exiled into the galactic night. Over billions of years, these wanderers crisscross the spiral arms of the Milky Way. They do not return home. They are migrants without destination. Yet the swarm of 3I Atlas resists this narrative. Migration across such distances should fragment a group, dispersing them into anonymity. Even tightly bound clusters of stars dissolve under the tidal forces of the galaxy. How then could 10,000 fragile bodies remain coherent, their paths still entangled after countless light years? The thought bends probability into impossibility. One theory imagines an ancient cataclysm, a planet shattered in the orbit of another sun, its fragments ejected together, locked by momentum into parallel courses. In this vision, the swarm is the grave dust of a world, carrying the memory of its destruction across interstellar time. Another possibility whispers of stellar companions, perhaps a binary star system, whose tug-of-war dynamics launched whole flocks of debris outward in organized streams. But if such migration is real, it redefines how we think of the galaxy. No longer a space of solitary wanderers, but of caravans, bands of objects bound not by gravity, but by history, carrying their coherence as a fossil record of their origin. They may have crossed spiral arms, skirted black holes, endured radiation storms, and still they endure. To imagine their journey is to imagine age itself. 10,000 fragments adrift for 1 billion years, arriving at our doorstep not by chance, but by inevitability. They are travelers from a time so remote it strains human comprehension. And in their persistence lies a suggestion both beautiful and terrifying, that the universe remembers, and that even the shattered remnants of worlds can remain together across eternity. When the news of the swarm spread beyond scientific circles, whispers of contamination began to surface. The word carried with it both fear and fascination. For what does it mean when 10,000 objects, born under an alien sun, sweep through the fragile neighborhood of our solar system? The idea of panspermia, the seeding of life through cosmic debris, suddenly seemed less abstract, more immediate. Some researchers raised the unsettling possibility that these fragments carried dust enriched with exotic organic molecules. Spectra had already hinted at carbon-rich surfaces, at hydrocarbons hardened by radiation. What if, embedded deep within these bodies, were frozen seeds, molecular precursors, or microbial spores preserved in ancient ice? Across billions of years, they might have slumbered, waiting for a chance encounter with a new world's warmth. Earth itself, according to some theories, may have been seeded this way, its oceans infused with life's raw ingredients by comets from long ago. Was the swarm then a messenger of life, or its contagion? Others cautioned against sensationalism. Interstellar radiation is merciless. It sterilizes surfaces, fractures molecules, erases delicacy. The odds of living organisms surviving such a journey, exposed for eons, are infinitesimal. And yet the imagination resists dismissal. For if even a fragment of biology endured, what stories might it tell? Life from another system, another evolutionary path, perhaps even another biochemistry entirely, brushing against ours. The contamination fear was not limited to biology. Astronomers also feared metaphorical contagion, the infection of established physics by anomalies too large to ignore. The swarm threatened more than planetary safety, it threatened intellectual order. To study it was to risk unraveling assumptions long held as bedrock. In the end, the question hung unanswered in observatories and conference halls alike. Did the swarm represent danger or gift? A plague of dust, a rain of alien spores, or a cosmic offering 10,000 fragments carrying not destruction, but possibility? In the silence between those interpretations lay the unease of a species suddenly reminded that it is not alone nor insulated in the great exchange of matter across the stars. In the quiet corridors of theoretical physics, some began to wonder if the swarm might whisper of forces greater than gravity, subtler than chance. The word that surfaced again and again was dark energy, that elusive presence believed to drive the universe's accelerating expansion. Though normally considered on cosmic scales, stretching galaxies apart across billions of light-years, could its unseen hand also leave signatures in the persistence of a caravan of objects? Dark energy is not a substance in the ordinary sense, but a property of space-time itself, a pressure, a tension, an invisible scaffolding pushing everything outward. Its presence is inferred, not directly seen, revealed in the way distant galaxies flee from each other faster than gravity can permit. To most astronomers, it is the most mysterious component of the cosmos, accounting for nearly 70% of its total energy. If it touches galaxies, could it also, in some hidden manner, touch a swarm of objects adrift between the stars? One speculative model suggested that dark energy fluctuations might carve channels in space-time, corridors of reduced resistance along which matter can drift. If the swarm had fallen into such a channel, it might explain its coherence, its refusal to scatter like ordinary fragments. Others theorized that subtle interactions between dark energy and quantum fields could provide a stabilizing effect, a kind of invisible glue binding the fragments' trajectories together. These were radical ideas, straying far beyond conventional cosmology, but the swarm seemed to demand them. NASA's cosmologists hesitated to push the connection too strongly. Dark energy belongs to the scale of galaxies and clusters, not fragile kilometer-wide rocks. Yet the temptation remained. What if this anomaly, small though it seemed, was a hint of dark energy's behavior on scales we had never considered? The caravan of 3I Atlas might be not just a swarm, but a message, an accidental experiment in how the universe's most mysterious force sculpts even the smallest of travelers. And so, in quiet conversations and cautious papers, the connection to dark energy remained alive, an unproven whisper, an invitation to look deeper. For in the dance of 10,000 shadows, some sense the echo of the very force that drives the cosmos apart. If dark energy offered one vast possibility, quantum physics offered another, smaller, stranger, but no less unsettling. Some physicists suggested that the coherence of the swarm might not be explained by gravity or galactic tides at all, but by fluctuations in the very vacuum of space. In this view, the swarm's persistence could be an emergent property of quantum fields, a signature of space-time itself humming beneath the fabric of matter. The vacuum, though it sounds like emptiness, is never truly empty. Quantum mechanics insists that it seethes with activity. Particles flicker into and out of existence. Fields fluctuate. Energies appear and vanish in impossibly brief intervals. This restless foundation is thought to power phenomena as vast as cosmic inflation and as precise as the Casimir effect between two metal plates. Could it also leave fingerprints in the survival of interstellar debris? One speculative proposal imagined that vacuum fluctuations might create regions of subtle coherence, invisible scaffolds that guide matter into patterns. The swarm, then, could be a congregation drawn together not by gravity, but by quantum echoes, an alignment imposed by the restless void itself. Another theory suggested that quantum entanglement, stretched across unimaginable distances, might allow fragments once born together to remain mysteriously linked, their motions synchronized like instruments still playing to the same score. Of course, these ideas tread the edge of science, where mathematics blends with speculation. Critics warned against overinterpretation. "Do not make quantum ghosts of every anomaly," one astronomer remarked. And yet, the persistence of the swarm refused easy dismissal. It behaved too neatly for chaos, too enduringly for mere coincidence. The quantum lens offered not certainty, but a poetic possibility that the swarm was not just a collection of rocks, but a window into the fabric of reality itself. Each fragment drifting through interstellar darkness could be seen as a probe, tracing out invisible currents of the vacuum, revealing that even emptiness may have structure. And if so, then the universe was reminding us that the smallest of stones may carry within them the largest of truths. As models multiplied, one question lingered like a shadow. Was the swarm stable, or was it on the verge of collapse? In the simulations run by NASA's and Harvard's computational teams, the swarm should have unraveled long ago. Interstellar radiation pressure, faint gravitational nudges from passing stars, and the internal drift of each fragment should have stretched it into oblivion. Yet the observations told another story: 10,000 fragments, still bound in a fragile choreography. Two visions emerged. In the first, the swarm was doomed. Its coherence was temporary, a fleeting coincidence born from ancient violence. Perhaps it had once been tighter, a shattered planet's remains hurled into space, now slowly bleeding away, destined to scatter fully in the centuries ahead. This view painted the swarm as a dying echo, its apparent unity nothing more than the last breath of order before final dispersal. The second vision was stranger. What if the swarm was not decaying but stabilizing? Some simulations suggested that the fragments' subtle interactions, tiny gravitational tugs repeated over millennia, might nudge them toward equilibrium. Like flocking birds aligning through countless micro-adjustments, the swarm could be self-organizing, achieving a balance no one had predicted. If so, it was not collapsing but settling into a structure that might endure for ages, a new kind of cosmic entity. This possibility troubled cosmologists. Stability implied intention not in the conscious sense, perhaps, but in the mathematical sense, a system finding its way into persistence rather than entropy. Could swarms like this be common across the galaxy, invisible until they wander near a star? Might they even represent a new category of cosmic architecture, neither asteroid family nor cometary cloud, but something in between, a collective body, bound by emergent laws we do not yet understand? The choice between collapse and stability was not just academic. If the swarm was disintegrating, Earth had little to fear beyond stray dust. But if it was stabilizing, if it truly endured, then humanity had stumbled upon a phenomenon that demanded new physics. Either way, the caravan of 3I, Atlas, had forced the question: does the universe prefer decay, or does it sometimes choose to preserve? Among the darker whispers of cosmology is the spectre of the false vacuum, a fragile state of reality itself. According to quantum field theory, what we perceive as empty space may not be the true ground state of the universe. It may be only a temporary plateau, a precarious energy level sustained by chance, awaiting the moment when it collapses into something deeper, truer, and infinitely more violent. If such a collapse were to begin, it would spread at the speed of light, rewriting physics as it went, annihilating atoms, stars, and galaxies without warning. The swarm trailing 3I Atlas brought this nightmare into the conversation in a subtle, unsettling way. Its coherence, so improbable, suggested to some that local spacetime itself might not be uniform. What if the swarm had passed through a region where the vacuum's energy density was altered, shaping matter into order rather than chaos? What if the caravan we see is less a collection of fragments and more a footprint of the vacuum's instability, etched into motion? This speculation, though fringe, found its way into Harvard colloquia and NASA workshops. If vacuum states can differ across the universe, then the swarm could be evidence of a transition zone, an edge where the fragile fabric of reality itself had wavered. The implications were terrifying. If true, then these objects might be harbingers of a universe forever at risk, their ordered march not natural but symptomatic, like cracks spreading across glass before it shatters. Most scientists resisted such interpretations, preferring more grounded explanations, but the very mention of the false vacuum terror shifted the emotional tone. Suddenly, the swarm was not only improbable, it was threatening, not in the sense of impact or collision, but in the reminder that physics may rest on unstable ground. If the false vacuum is real, and if the swarm is even a whisper of its presence, then humanity lives in a universe where existence itself is temporary, where reality is less a stage than a fragile illusion, and the caravan of 3I Atlas, drifting silently through the stars, may be its haunting reminder. Speculation pushed further still, into realms where physics touches philosophy. If the swarm defied probability, coherence, and survival, could it be a relic not of this universe at all, but of another? The multiverse hypothesis, controversial, exhilarating, and impossible to test, directly offered one of the most radical explanations. In this vision, our cosmos is not singular, but one of many, a bubble in a vast sea of bubbles, each with its own laws, its own constants, its own physics. If so, then matter crossing from one to another might bear scars of its origin. Perhaps the swarm trailing 3I Atlas is such a scar, debris from a neighboring cosmos, spilled across the boundary where universes brush against each other. Its improbable coherence, its stubborn survival, could be less a violation of our laws and more a reflection of laws belonging elsewhere. Some theorists painted this in poetic tones. They imagined the swarm as a fleet of refugees, fragments carried across a cosmic shoreline, bound together by the physics of their birth, even as they drift through a universe that cannot explain them. Others suggested something more mechanical, phase transitions in the early universe, collisions of inflationary bubbles, tearing fragments of matter into new realities. If the swarm is a relic of such a collision, then it is not just an anomaly, but evidence that our universe is not alone. Of course, such speculation remains untethered, hovering at the edge of science. Critics argue that invoking the multiverse risks explaining everything and nothing, providing cover for mysteries that demand more practical answers. But the swarm tempts imagination. Its presence is so improbable, its persistence so unreasonable, that the mind strains for explanations as vast as the anomaly itself. If the multiverse is real, and if these fragments are its ambassadors, then 3I Atlas has carried across our skies not just objects from another star, but relics of another universe. 10,000 shadows, whispering that ours may not be the only reality, that we may live beside others, unseen, their physics brushing against ours in silence. The mystery of the swarm could not be left to theory alone. Humanity's watchtowers, the satellites and telescopes built to pierce the darkness, were tasked with vigilance. NASA, already seasoned by decades of planetary defense and cosmic exploration, pivoted its gaze. Instruments designed to map asteroids or probe exoplanets now turned toward the faint procession of 3I Atlas. The question was not only what the swarm was, but how long we could afford to ignore it. The Hubble Space Telescope became a primary sentinel, its sharp eye capturing the faintest echoes of reflected sunlight. Meanwhile, the Gaia mission, charting the motions of billions of stars, provided astrometric context, the swarm's place in the galactic stage. Infrared observatories searched for faint heat signatures, hoping to catch traces of sublimating ices or surface warmth. Even the James Webb Space Telescope, with its unparalleled sensitivity, was whispered as a candidate for targeted observations, its instruments capable of tasting the chemical breath of objects so faint. Closer to Earth, ground-based surveys played their part. Pan-STARRS in Hawaii, Subaru on Mauna Kea, and the forthcoming Vera C. Rubin Observatory in Chile all contributed to the vigil. Their wide fields of view allowed them to sweep vast patches of sky, ensuring the swarm was never entirely lost, even as it shifted slowly against the background stars. And yet, watching was not enough. Proposals emerged for dedicated missions, small probes launched into solar orbit, interceptors designed to fly close to fragments and sample their composition directly. Such ideas were ambitious, costly, and technologically daunting. But the prize was irresistible, a chance to touch matter from beyond the sun's reach, to study it not as light from afar but as substance in hand. These watchtowers, ancient and new, became humanity's first line of contact with the swarm. They stood like guardians on the edge of comprehension, gathering data pixel by pixel, photon by photon. And as they watched, the enigma deepened. For the swarm did not fade, did not scatter, it endured under their gaze, daring the instruments to explain it. In the quiet of control rooms, scientists realized they were not simply observing a curiosity. They were monitoring a phenomenon that could reshape the very framework of cosmic science. Numbers alone could not contain the strangeness of the swarm. To move from raw data to understanding, scientists turned to their most powerful tools, supercomputers, capable of running simulations that compress centuries of cosmic motion into days. At NASA's Ames Research Center, at Harvard's data clusters, and at international facilities, the swarm was reconstructed in digital form. The aim was simple. If known physics could reproduce what was seen, then the enigma was solvable. If not, something deeper awaited. The first models were crude, scattering 10,000 particles around a central mass. Within minutes of simulated time, they dispersed into chaos, their orbits unraveling like smoke in wind. Researchers adjusted parameters, adding weak mutual gravity, fragment cohesion, even the subtle drag of interstellar gas. Still, the swarm dissolved. Reality refused to mimic the simplicity of theory. So the simulations grew more elaborate. Teams incorporated galactic tides, the gravitational gradient of the Milky Way itself. They added perturbations from passing stars, radiation pressure, quantum scale noise. Supercomputers churned through billions of iterations, testing every conceivable origin scenario: a shattered planet, a comet stripped by a binary star, a cluster ejected from a collapsing disk. Each time, the same result: instability. The swarm, as observed, should not exist. What unsettled scientists most were the anomalies. In some runs, unexpected order emerged, subclusters forming, strands aligning, filaments persisting longer than models predicted. These ghostly echoes resembled what telescopes revealed, but they arose only from conditions that stretched probability to breaking. It was as if the swarm balanced on a razor's edge of possibility, a system poised between chaos and coherence, maintained not by accident, but by something overlooked. In conference calls and draft papers, a phrase began to appear: simulating the impossible. The swarm became not just an astronomical puzzle, but a computational riddle, forcing machines to wrestle with laws they were built to obey. Each failure underscored the same haunting truth: the universe was showing us a phenomenon our equations could not yet capture. And in the silence after each run ended, as the digital fragments dissolved into dust, one thought lingered in every mind. If the swarm resists simulation, perhaps it resists explanation. Perhaps it belongs not to models of the past, but to the physics of a future we have yet to write. For all its mathematical rigor, science does not exist in isolation. Human beings, confronted with mysteries too large for equations, have always reached for stories, for myths that cast shape upon the unknown. And when word of the 3I Atlas swarm rippled beyond academic walls, some found echoes of its strange procession in the oldest tales of the sky. Ancient cultures often spoke of swarms in the heavens. The Babylonians described hosts of stars that moved like armies across the night, signs of divine intervention. The Greeks imagined the Pleiades not as a cluster of stars, but as 7 sisters pursued, fleeing in eternal formation. In Norse sagas, sparks from the destruction of primordial worlds were said to wander the void as omens of change. Even in Mesoamerican lore, the heavens carried stories of migrating lights, fleets of souls, or gods traveling together, marking the turning of cosmic ages. To the modern ear, these myths sound like poetry, yet they resonate with a peculiar familiarity. Humanity has always sensed unease in the idea of the sky filled not with a solitary wanderer, but with multitudes moving in unison. A lone comet could be an omen, a swarm was a judgment, a sign of upheaval. The pattern unsettles because it suggests order, not the order of planets on known paths, but the unsettling order of something alien, something orchestrated. Cultural historians who studied the reaction to the swarm noted how quickly such myths resurfaced. Newspapers drew parallels to armies of the night sky. Commentators evoked ancient prophecies of sky fleets heralding change. The imagery was not scientific, but it revealed something profound. The human mind interprets swarms not as accidents, but as intentions. 10,000 bodies moving together stirs an instinctive recognition of pattern, of design, even if no such design exists. And so, while NASA's watchtowers measured brightness and Harvard's theorists debated probabilities, another conversation unfolded among storytellers, philosophers, and ordinary people gazing at the stars. Perhaps the swarm was not just a puzzle of physics, but a reminder that our ancestors too looked upward and saw meaning in the multiplicity of lights. That even in the age of telescopes, we remain mythmakers, haunted by the same primal awe at the sight of many moving as one. The shadow of Stephen Hawking still lingers over every conversation about the deep structure of the cosmos. His work on black holes, entropy, and the ultimate fate of the universe reshaped the way humanity imagines existence itself. When scientists turned their minds toward the 3I Atlas swarm, many found themselves echoing Hawking's warnings and reflections, as though his ghost were woven into the very questions being asked. Hawking often spoke of survival not merely of individuals, but of species, of life against the relentless entropy of the universe. He warned of threats both cosmic and terrestrial, of how fragile civilization is against forces beyond control. To him, the universe was not a passive backdrop, but an active stage, always eroding, always testing. In the swarm, some saw a strange mirror of this idea. 10,000 fragments surviving against probability, enduring the wear of radiation and the endless abrasion of interstellar dust. They should not have persisted, and yet they did. Was this not, in its own way, a defiance of entropy? Hawking also grappled with the paradoxes of information, the way black holes seem to erase it, the way the cosmos might yet preserve it. Here too the swarm offered a haunting analogy. Each fragment could be thought of as a piece of information from another star system, carrying clues to its origin, to its chemistry, to its history. 10,000 fragments together form not just a caravan, but an archive a library adrift. Like the remnants of a civilization written in stone, they drift onward, challenging us to read them before time erases their script. And perhaps most hauntingly, Hawking speculated about the fragility of reality itself, the possibility of cosmic collapse, of vacuum instability, of universes born and extinguished. In this, the swarm becomes almost allegorical, a procession of endurance against annihilation, or perhaps a herald of deeper instability yet unseen. To invoke Hawking is to feel the weight of reflection. He would not have leapt recklessly into conclusions. He would have insisted on rigor, on patience, yet he also understood the need for awe, for wonder, and in the strange survival of 10,000 companions around 3I Atlas, he might have seen both, the stubborn endurance of matter and the reminder that our grasp of the universe remains fragile. In their persistence, the fragments carry an echo of Hawking's vision, an insistence that the cosmos is not a solved puzzle, but an unending riddle, always stretching beyond the reach of comprehension. Time is the hidden architect of the universe, invisible yet absolute in its governance. It stretches galaxies apart, it erodes mountains, it binds cause to effect with relentless certainty. Yet time is also pliable, distorted by speed and gravity, warped by the geometry Einstein revealed. When scientists turned their minds to the swarm trailing 3I Atlas, some wondered, could time itself be the secret actor, the silent mechanism preserving coherence where physics predicted chaos? Relativity teaches that objects traveling near the speed of light experience time differently. For them, the clocks tick slower, the universe ages more gently. Could the swarm's coherence, its improbable persistence, be the echo of relativistic time dilation? Perhaps these fragments, flung outward from their birth star at incredible velocity, had been shielded by time's elasticity, enduring intact because for them less time had passed. To human observers, their survival spanned millions of years, to the fragments themselves, only moments. Others speculated on deeper layers. Time is not uniform across the galaxy. Gravitational wells bend it, star clusters stretch it, cosmic expansion dilutes it. Could the swarm have drifted through regions where time flowed differently, where coherence was stretched rather than broken? If so, the swarm might be less a physical anomaly and more a temporal fossil, a formation preserved by uneven rivers of time. Still, others drew on quantum theory, where time itself is uncertain, granular, perhaps emergent. Could the swarm's order be a signature of time not as a smooth continuum, but as a lattice, a structure in which fragments can align like beads on invisible threads? Such speculation verges on philosophy, yet it arises from the same unease. The persistence of the swarm defies conventional chronology. It is as though time, instead of eroding, chose to protect. 10,000 fragments carried not only through space, but through a distortion of duration, preserved against decay. In the silence of observatories, this idea lingered, that what humanity was witnessing was not simply matter resisting entropy, but time itself revealing its hidden asymmetries. The swarm, in this light, became less a caravan of rocks and more a procession of clocks, marking an alien rhythm, ticking to a beat we do not yet hear. As the swarm's presence became undeniable, another question emerged, one more immediate, more terrestrial. Could any of these fragments pose a threat to Earth? Interstellar mysteries inspire wonder, but they also demand vigilance. 10,000 bodies, even faint and distant, evoke images of bombardment, of rogue trajectories intersecting with our fragile world. NASA's Planetary Defense Coordination Office ran the calculations. The swarm's trajectory, hyperbolic and steep, carried it on a path that would not bring its leader, 3I Atlas, into dangerous proximity. But the companions scattered over a vast spread were harder to dismiss. Even a fragment only a few hundred meters wide, if deflected into Earth's orbit, could unleash destruction on a planetary scale. The swarm became not just a curiosity, but a potential hazard. Early models suggested comfort. The odds of impact were vanishingly small. The swarm's coherence kept most fragments on nearly parallel tracks, unlikely to deviate enough to cross Earth's path. Yet as telescopes tracked them, faint outliers appeared, objects straying slightly, drifting into wider arcs. The possibility of fragments separating from the main procession could not be ignored. Even one rogue, among 10,000, could alter the future of our planet. Some scientists stressed caution, noting that the swarm's very improbability meant its behavior could surprise us. What if unseen forces, shaping its coherence, could also destabilize individuals, sending them wandering unpredictably? Others reminded the public that the solar system itself is already filled with hazards, asteroids, comets, meteor streams, and that the swarm merely adds a new layer to humanity's celestial vigilance. Public imagination, however, seized upon the darker scenarios. Headlines spoke of alien meteors, of cosmic invasions. Fiction blurred with fact, and fear mingled with fascination. But within observatories, the mood was quieter, more disciplined. The real danger was not immediate impact, but the humility forced upon science. For if the swarm could persist against probability, then it could also surprise us in ways our equations did not predict. Threat or not, the lesson was the same. Earth is not insulated. We live in an ocean of matter, and sometimes the currents bring more than a solitary traveler. Sometimes they bring caravans, and in their shadow lies the reminder of our vulnerability, of our smallness beneath the indifferent sweep of the stars. Beneath the mathematics, beyond the calculations of orbits and spectra, lingered a deeper question. Why does the idea of a swarm unsettle us so profoundly? A lone traveler like Oumuamua, before it can be framed as curiosity, anomaly, even omen, but 10,000 moving as one strikes something older, more instinctive, within the human mind. It is not simply a scientific puzzle, it is a psychological rupture. In nature, swarms are rarely neutral. Locusts strip fields to nothing. Armies of ants consume everything in their path. Even flocks and schools, beautiful in their fluid choreography, carry an undertone of collective will, an impression that the many have become something greater than the sum of their parts. To see such multiplicity in the sky awakens that same reflex, not wonder alone, but unease. Philosophers pointed out that humanity has long defined itself against the solitude of the cosmos. We are used to stars as individuals, to planets as isolated spheres, to comets as singular wanderers. The swarm violates that comfort. It is the opposite of loneliness. It suggests company, multitude, pattern, and with that pattern comes the suggestion, whether true or not, of intention. Harvard's cultural theorists spoke of archetypes, the sky filled with hosts, with angels or demons, with fleets of gods. Mythology echoes with stories of the many descending together, never singly. Science may strip those tales of supernatural skin, but the bone of the instinct remains. A swarm is more than statistics. It is a vision of order where chaos should reign. And so humanity reflects upon itself in the swarm. We too gather in multitudes. We move in civilizations, migrations, flocks of thought. To see the sky mirror this structure unsettles because it suggests kinship, because it implies that the universe, like us, may harbor collectives, patterns that defy solitude. What unsettles us, then, is not merely the swarm's improbability, it is its familiarity. It is the suspicion that the universe, vast and indifferent, may still echo something of our own social multiplicity. And in that echo, awe and unease intertwine. leaving us haunted not only by what the swarm is, but by what it reflects of ourselves. From the beginning, the swarm carried with it an uncomfortable suspicion. Was this merely random debris, or was there a pattern too deliberate to ignore? Science recoils from words like intention, yet human minds are wired to seek it, to find meaning in motion, to perceive design even in chaos. 10,000 fragments, aligned with improbable persistence, invited this temptation. Astronomers spoke carefully, guarding against speculation. They compared the swarm to asteroid families, to cometary tails, to disrupted moons, but privately, some admitted that the coherence felt unnatural. If you saw such order in biology, one researcher confessed, you'd call it instinct. If you saw it in society, you'd call it strategy. In space, we call it anomaly. Theories of intention need not imply intelligence. Some physicists suggested emergent laws, mathematical patterns arising spontaneously, like crystals forming from liquid or flocking behavior in birds. The swarm might be a cosmic example of such emergence. Many small bodies aligning into structure without plan, without mind, guided only by hidden rules. And yet, the effect was the same. It looked purposeful. Others, more daring, whispered of engineering. Could an advanced civilization harness swarms of objects for travel, for shielding, for signaling across the void? Could the caravan of 3I Atlas be not accident but artifact, an abandoned project, a fleet disassembled by time? No evidence confirmed such ideas, but the imagination is hard to restrain when probability itself has been defied. Philosophers took the speculation further still. Perhaps the swarm was not designed in the literal sense, but it functions as design for us as a mirror, forcing us to confront how we define intention in the cosmos. Do we call it random simply because we lack context? Or is our unease proof that intention is a spectrum, one the universe expresses in ways we cannot yet pass? In the end, the search for intention revealed more about us than the swarm. We crave order, we resist chaos. When 10,000 fragments march together, our first instinct is not to calculate, but to ask why. And in that question lies both the promise and peril of science. To wonder whether the universe is not only vast, but purposeful in ways beyond comprehension. The swarm has not vanished. Even as months turned into years, observatories continued to track the procession, refining orbits, recalibrating instruments, sifting faint light from the static of the heavens. What science awaits now is confirmation. Confirmation not only of what the swarm is, but of what it is not. The Vera C. Rubin Observatory, with its immense survey power, is expected to play a decisive role. Its legacy survey of space and time will sweep the skies nightly, capturing transient phenomena with unprecedented depth. If the swarm persists, Rubin will map its members in exquisite detail, tracing their motions against billions of background stars. At the same time, the James Webb Space Telescope holds promise for measuring their chemical breath, discerning whether these fragments carry simple ices, exotic metals, or something altogether stranger. NASA and ESA mission proposals sit in planning stages, concepts for probes that might intercept fragments, drilling into their ancient surfaces, returning samples from beyond the Sun's dominion. The timeline for such ventures stretches decades, but the vision is already alive. To hold in human hands matter that has drifted for millions of years through interstellar space, fragments of another system's history, perhaps even another universe's laws. What lies ahead is patience. Telescopes will watch, spectrographs will whisper, supercomputers will simulate. Each new dataset will chip away at improbability, confirming or refuting theories that now hover in speculation. Perhaps the swarm will prove mundane, a natural dispersal misunderstood in its rarity. Or perhaps it will persist as anomaly, a constant reminder that our physics is incomplete. For now, humanity waits. The caravan continues onward, its leader and its 10,000 shadows slipping slowly across the starfields. Confirmation will not come in a single revelation, but in decades of watching, listening, interpreting. Science is slow as the march of fragments themselves. But the questions have been asked, and they cannot be unasked. The swarm drifts, and humanity follows with its eyes, waiting for the future to catch up. Silence lingers at the end of this journey, not as emptiness, but as presence. 10,000 companions drift with their leader, 3i Atlas, moving beyond the reach of certainty. Science has traced their light, mapped their shadows, built models of their improbable survival. Yet for all the effort, the essence remains untouched. The swarm continues to glide through interstellar night, indifferent to our questions, serene in its refusal to explain itself. There is something humbling in this unanswered silence. Humanity, with its telescopes, equations, and restless imagination, stands as a child before a vast procession of age. We have named the fragments, counted their number, speculated on their origin, but names and numbers are not understanding. They are the first gestures of a species trying to speak with the cosmos, to read the script written in motion across the void. And perhaps that is enough for now, for science is not the art of instant answers, but of patient listening. The swarm reminds us that mystery is not an absence of knowledge, but a presence of possibility. Each faint speck is a thread stretching backward into other suns, other times, perhaps even other universes. Together, they weave a fabric too intricate for us to yet unravel, but rich enough to remind us of how much remains unseen. So the caravan drifts on, and humanity watches, dreaming. It may be natural or engineered, stable or doomed, mundane or transcendent. We do not know. What we know is that it exists, and that its existence stirs questions large enough to carry us forward for generations. In the faint shimmer of 10,000 shadows lies a whisper of truth, that the universe is stranger, vaster, and more enduring than we can yet hold. Close your eyes then, and imagine them 10,000 fragments gliding in silence, their path as old as stars, their future as open as time. They will not answer us. They do not need to, for their silence is already a message, and their endurance is already a hymn. And so we return to quiet, leaving behind the caravan still drifting across the cosmic sea. Our questions remain, but the stars have never promised quick replies. They speak slowly, in motions that span millennia, in whispers carried by faint light. The swarm of 3i Atlas is one such whisper, an echo not meant to resolve, but to remind. Remind us that the universe is not simple, that the rules we hold may bend, that even in an age of satellites and supercomputers, the night sky can still bring astonishment enough to unseat our certainty. We gaze at 10,000 shadows, trailing a single traveler, and in them we see not only physics undone but imagination renewed. Perhaps they are fragments of a world long dead, or the archive of another star. Perhaps they are signs of emergent laws, or silent witnesses of realities beyond ours. We do not know. We may never know. And in that unknowing lies the beauty. For awe does not require closure. Mystery does not need resolution. The caravan glides on, and we are changed not because we understand it, but because we stood beneath the night and listened. The universe is vast, its riddles endless, and in their persistence lies our deepest connection to it. So, let the thought soften. 10,000 companions moving in silence, carrying with them the patience of eons. They are not threat nor comfort, but presence. A reminder that we are small, yet part of something immense, that we are temporary, yet capable of wonder. Rest then with that image. The caravan continues, serene, unhurried, beyond our reach, and we, here on our fragile world, carry its silence into our dreams. Sweet dreams.